In this video, we're going to be looking at modeling exponential relationships. We have seen in previous lessons that exponential relationships are relationships that change by the same percent for each unit of time. For example, the population of a town may be growing by 4% every year, or the value of a car may be decreasing by 10% every year. We will be looking at writing equations that model those types of situations. And just a reminder, linear relationships change by the same absolute value, not the same percentage. For example, population may be increasing by 400 people every year. It is a certain number that is changing from year to year, not a percentage. Here's my equation to represent exponential relationships. Q equals Q sub 0 times 1 plus r to the t power. Q stands for quantity, and Q sub 0 is the quantity at time 0, or my initial amount. R is the growth rate, written in decimal form, and it's usually given to you as terms of percentage in the word problems that we're going to be looking at, and T is for time. If the relationship is exponential and indicates growth, my graph is going to be increasing, so R is positive. My rate is positive, which is bigger than 0, so 1 plus r is going to be more than 1. If my exponential relationship indicates decay, that means I'm decreasing in value, so my graph is decreasing. My r value is going to be negative, so 1 plus r is going to be less than 1. Problem 1. If the price of a computer chip increases by 2% every year, what would R be in the formula? Well, remember that R needs to be written in decimal form, and since we're increasing, I know that it is going to be a positive value, so this is 0.02. Problem 2, if the number of bacteria decreases by 7% every hour, what would R be in the formula? Since it's decreasing, it's negative. 7% is 0.07. Problem 3, determine whether the graph of each of the following is increasing or decreasing. Problem 3a. Here I have 1.06 as the base. This number is more than 1, so it's more than 100% of the value that we had last time, whether it was last year or last second, last hour. My growth rate here of R is 0.06 or 6%. As long as this number is more than 1, we are increasing. So this is increasing. Problem B, again, I have a number that is more than 1. That is increasing. Problem C, I have a number that's less than 1. This indicates I only have 87% of what I had the previous unit of time. So this is a decreasing relationship. And problem D, 0.92, a number less than 1, that indicates decreasing. So again, if this is more than 1, it is increasing. If this number is less than 1, it is decreasing. And in this course, we are never going to be looking at exponentials that have a base here that is negative. The number inside the parentheses are never going to be negative. Problem 4, determine whether the graph of each of the following is increasing or decreasing and determine f of 0. That means the function value at 0. So first of all, I see that this is less than 1, so this is decreasing. And I want to find f of 0. So I'm putting 0 in place of x. So when you put this into your calculator, you get 600. Problem B, this number in the parentheses is more than 1. So that is increasing. And here I'm asked to find f of 0, so I put 0 in place of x, and I end up with 12,000. One thing I want you to notice about this is that this number that I end up with is this number that's in front of the parentheses, and it just didn't happen to be that way. F of 0 means time at 0, and my formula has that q sub 0 as the initial quantity or the quantity at time 0. So you really don't even need to put 0 in place of x and put this in the calculator in order to answer that question. Your quantity at time 0, or f of 0, is the number that's in front of the parentheses. Now, problem 5, the population of a town is 80,000 and it has a constant growth rate of 4% per year. Write a function to model this situation. Okay, so let me start off by writing down my general formula. Now, the population of a town is 80,000. That's the quantity that I start with. That's q sub 0. It has a constant growth rate of 4%. So my r is positive, and it's 4% as a decimal would be 0.04. So this equation is going to be 80,000 in place of q. And then in place of r, I put 0.04, and that is to the t power. Now I want to go ahead and add those two numbers inside the parentheses. And that's the equation that I would put into my math lab. Be sure that you're using the correct variable for what they're asking in that particular problem. Again, notice that I have 1.04 inside the parentheses. That's more than 1. That indicates growth. The next part of this problem asks me to determine the population in 6 years. So I'm just going to put 6 in place of t. And then you would put this into the calculator. And you get the quantity 100 and 1,226. Right. And again, we round into the nearest whole number here, because we're talking about people. Problem 6, the population of Harperton, that's a typo there, that A should not be there. The population of Harperton is 40,000 and is decreasing at a rate of 2% per year. Write a function to model the situation, determine the population in 5 years, and round to the nearest whole number. This problem, I am decreasing at a rate of 2%. So my rate is negative 0.02. My q sub 0 is 40. I'll go ahead and write r equals. So my formula for this relationship is going to be q equals 40,000 times 1 minus 0.02 to the t power. So q equals 40,000 times 0.98 to the t power. The second part of this problem asked me to determine the population in 5 years, so we put 5 in place of t, and we have 36,157 as my answer. Problem 7, the cost of the raw materials to make a certain product at a factory was $2,000 in the year 1998. The cost is increasing by 3.5% per year. Write a function to model this situation and determine the cost of the raw materials in the year 2020. Okay, there's my equation. You can see that my R value is 0.035, and here is that equation simplified. Now the next part of this problem says to determine the cost of the raw materials in the year 2020 and round to the nearest cent. Okay, so I need to figure out what T is. I want to know the cost in the year 2020, and my Q sub 0, or time 0, was actually 1998. Right? We're not going back to the year 0. So this is actually 22 years that we've been looking at the cost of the raw materials. So I'm going to put 22 in place of T. And there is my value after 22 years. Problem 8, the value of a tractor was originally $150,000 and is depreciating 20% every year. Write a function to model the situation and determine the value of the tractor after 7 years, round to the nearest cent. Okay, the value is depreciating. That means it's going down. So my rate value here is negative 0.20. So here's my equation. Here's my equation simplified. And for the second part of the problem, we're going to put 7 in place of T. And there's my final answer. Between 1980 and 2010, the growth rate for the number of employees at Alexander Steel Company was 3% per year. If the number of employees in 1980 was 200, then what was the number of employees at the end of 2010? Round to the nearest whole number. The situation that we have here shows a growth rate. So my R value is positive. So my R value is 3%. So as a decimal, that's 0.03. My initial value, my starting amount, the number of employees I start with in the year 1980 is 200. So this is my equation. And just as a point here, my math lab may not ask you to write the equation, they just may want the final answer. And in this case, I need to figure out what T is. So I want to look at this problem here just slightly different than we've done before. If I am starting here with the year, and I want to know what T is, my initial starting time is 1980, so that's T0. So 1981 would be 1 year, so T is 1. 1982 would be 2 years, so T is 2, and on like that. So what I want to end up with is the year 2010. So if I take 2010 and subtract 1980, I see that it's going to be 30 years. So I'm going to put 30 in place of T. And we put that into the calculator, and you get approximately 485 employees. Problem 10, between 1950 and 2000, the inflation rate was about 4.5% per year. If the cost of feeding a family of 4 was $200 in 1950, then determine the cost in the year 2000, round to the nearest cent. I want you to pause the video and see if you can try to do this problem on your own, and then come back and check your answer. And there is your answer for problem 10. Problem 11, if the population of a town is decreasing by 5% every year, that means the population of the town is 95% of the population the previous year. So when I'm looking at my formula and I have 1 minus 0.05 in the parentheses, then that ends up being 0.95. So this means that I have 95% of the population the previous year. My rate of change is 5%. Problem 12, a computer is purchased for $3,500. Its value each year is about 78% of the value the preceding year. Find the value of the computer after 8 years and round to the nearest cent. In this problem, this 78% is not my R. The 78% is actually the 1 plus r or 1 minus r. It's that whole thing that's in parentheses. Here's my general formula for an exponential relationship. The value of the computer at the beginning is $3,500. This 78% is the 1 plus r. The r has already been taken into account. R in this case is actually 22% decrease, so negative 22%. And here I'm wanting to find the value after 8 years, so I will put 8 in place of t, and you can put that into the calculator. And you have $479.54. Be careful with these problems where it's telling you the value the preceding year. Instead of saying my growth rate, here I have a different type of problem. This already tells me what the 1 plus r is. So just be careful with that particular problem when you do your homework.